All right, so why are we here? Lesson 20. The whole point of doing a review and teaching you about piecewise is because we want to apply transformations, which is what you have been learning, to piecewise functions. So I have these two types of transformations in this problem. I want to translate 5 units up and translate 3 units down, and we're going to use the piecewise function that you had in the previous video. We have previously done transformations like these in quadratics, absolute value equations, even exponential functions, but never in a piecewise. So we're going to do that today. In a piecewise, you're going to have different intervals, and so you have to apply this transformation to all the intervals separately. And we'll do it for one interval and we'll see how it changes. This is the piecewise function that we were working with in the previous video. And we have the equation for 3 of those intervals. I want to translate the 5 units up. How would I do this? Well, you would just like you did in other equations. You would add 5. So if we have, for example, x squared as our parent function, we would normally have to add 5 to that. And so this is no different. You're going to have to add 5. And because you already have the equation, I'm looking at my first interval here, 0.5x minus 0.5, then I would add 5 to that. When you add 5 to a negative half, your result will be a positive 4.5. So now your new equation is going to be y equals 0.5x plus 4.5. And that is the new equation for the transformation. If we wanted to translate this 3 units down, then we have to subtract 3. So our new equation is y equals 0.5x minus 3.5. The original equation had a negative 0.5, so if we're adding a negative 3 to that, that'll give us a negative 3.5, and that'll bring the whole function down 3 units. How would this look like in the graph? There you see in red when the transformation of 5 units up. And I'm going to go ahead and add the transformation for 3 units down so that you're able to see it in the same graph. There you see the change in the graph in red of 5 units up, and in dark blue, 3 units down. How would you do this transformation for the second interval, where we have y equals negative 2? Same thing. You would add 5, so now you have y equals 3. And if you want to move 3 units down, you would add a negative 3, which gives you y equals negative 5. Notice the endpoints. It went from negative 7, negative 4 to negative 7, 1. So we're adding 5. And then that endpoint is also going to change when we subtract 3. It's important to know how these numbers and ordered pairs are changing as you're moving and translating. Now what would happen if we wanted to apply a scaling to a piecewise? In a similar fashion, you would apply the scaling and do the math with the original interval equation. So if I want to add a scale factor of 1/2, for example, then I would just use 1/2 as the coefficient. Now because your original function already has a coefficient of 1/2, you would have to do some math. So in this case, 1/2 times 1/2 So your new slope is 1/4. And that, of course, is a lot smaller. So you will see the slope change because we went from a slope of 1/2 to a slope of 1/4. For the second interval, because you don't have an x to use a coefficient, then it wouldn't change. When you are scaling, you're applying that coefficient to the x value, but if you don't have an x value, or it would be irrelevant what the x value is, then it doesn't matter. Then it would always be y equals -2. For the third interval, though, your new function would be y equals 1/2 x minus 3.